For test 2, I will be discussing a hashing technique and a collision technique. But first, we want to know what is hashing. Hashing is a function, meaning that maps keys to a position in a hash table. The goal is to have fast insertion, fast searching, and fast deletion operations. The formula they use are different hash techniques. The key is for key and the M is for the size of the table. The method I chose for my hashing is the division method. It is one of the most simplest and most used hashing methods. The function is very simple. It is the key mod by the table size. Example, if the key is 59 and the table size is 10, the hashing for 59 will be 59 mod 10, which is 9, which will be the remainder. So from the division method, I've placed here some keys, hashing keys, 18, file 1, 22, file 4, 59, and table size is 10. To hash the first key 18, you mod it by 10, which will give you a remainder of 8, and include it in the table. 41 mod 10 will give you 1, that is index 1. 22 mod 10 will give you 2, index 2. 44 mod 10 will give you 4, that is index 4, and 59 mod 10 will give you 9, index 9. So the edge cases in division method, the choice of M is very critical. You need to use a prime number that is not close to the power of 2. Example, if you use a number like M, certain keys like 8, 16, and 24 will all go straight to 0. So it is best that you use a random looking and well distributed key. Now we're going to talk about the collision. So there are collision occurs when two keys hash to the same index, like 18 and 28. Both of them will hash to the same index of 8. To deal with collision, there is the technique of linear probing. If a collision is at index I, you add and you add the I to the key and you mod it by M. And I is 1, 2, or 3. It is as simple and fast to implement. It is just you will just look for the opening slot after the collision key. So example here, say I were to insert 28 into my table. Once I hash 28, I will get 8. But index 8 has 18 is in it. So I will use linear probing to find another key. So it will be the 28, you add 1 to it, and you mod it, which will give you the 29 mod 10, which is 9. But index 9 is already occupied. So you do it again, the same step, but you add 2. So once you add 2, you get 30. So 30 mod 10 is 0. So 0, you will add 28 into the index 0. So the indicators for linear probing is primary clustering. When you have groups, filled slots grow. Some of the slots are in the table that are clustered in one area of the table. Then it is wraparound. If it end reach, you have to wrap to the start. And in full table, insertion fails or needs rehashing. So there are Real world cases, they're compiler symbols or tables. These are used to store identifiers like variables and functions for quick access in programs. The hashing enables fast lookup. The division method computes the index and the linear program resolve the collisions. The pros of the pros for compilers is it is fast lookups and simple implementation. The cons is that the clustering, which I discussed before, reduced efficiency and the deletion is tricky. Another real world example are databases. Databases are used, the keys are used for in memory key lookups, fast in memory key lookups. These for equality based searches. Division method maps keys to index and the linear program resolve collisions. In this case, the pros is it is efficient for exact match queries and predictable performance, but the cons is it's not suitable for a range of queries and need resetting when full. Another one is the caching systems with CPUs and DNS. It is used to store frequently used data for fast access. The hash tables enables low latency retrieval. Linear probing keeps memory uses compact. The pros is that it is excellent for quick retrieval, reduces memory fragmentation. The cons is collisions reduce speed, resizing can be costly. Then there's the network routers for routing tables. Hashing helps map IP addresses to forwarding rules. The division method computes index and the linear probing handles the collisions. The pros is that there is fast lookups and it is scalable for many IP addresses. The cons, clustering may delay packet processing. Thanks for listening. So let's go to the coding demonstration. Now I will run the terminal to run the same example that I had before. You have the hash class, the constructor. This is the division method hash function, and this is for the linear probing. This is to display the the um the keys. So first of all, I had initialized the same numbers from in the presentation 1841 22 5459. I will run the code. Okay, so in inserting the initial keys, so key 18 is at index 8, key 41 is at index 1, in key 22 is at index 2, key 44 at index 4, key 59 at index 9. So this is how the hash table looks. Index 0 is empty, index 3 empty, index 5 empty, index 6 empty, index 7 empty. Now I will comment these to show the collision probing. So I have to save it and run it again. Okay, so I inserted 28. So there was a collision at index 8 and 9 as seen here. So they did the probing. They added, where is the probing? The probing code. Okay, so collision at index 8 and collision at index 9. Once there are keys there. and then you have to do the probing function here, the plus I, increment by 1, and then mod the table, and that's how they end up with index 0. So when I run the code, and so the new table index 0 has the 28. So that is it for my presentation. Thanks for listening.